So I and a million other people saw this video by Jess Codes called Draw Fewer Tiles by Using a Dual Grid System. In her video, she showcases a way that you can create a nice looking tile system, like this, using only 15 tiles, instead of the common approach, which is to draw 47 tiles. So I want us to go over this dual grid system, show why you want to use it, how you can implement it, and how you can perhaps get away with using only 5 base tiles instead of the 15 that Jess Codes uses. Some aspects of this video will be different from Jess Codes, in part because I quite often do side-scroller art, and as I said, I want to discuss this in the context of using only 5 base tiles, because drawing less is good. So to start, let me showcase a couple of examples of what you can achieve. This tiling that we can see here is done using only 5 tiles. This is also done using 5 tiles. Now, both of these look fairly nice, but with only 5 tiles, you're bound to see some repetition. But now, since you need fairly few base tiles, it's kind of easy to throw in a couple of extra alternative tiles. So now you can get something like this fairly non-repeating pattern using only 15 base tiles. And obviously, if you want a different type of top platform, so you want to handle rotations uniquely, that would also be possible. So you can get something like this, where the top platform is different from the sides and the bottom of the platform. But in this case, you would need at minimum 9 tiles instead of 5. So let me first just describe the issue we're trying to solve. In order to tile our game, we obviously technically only need 1 tile to make a tile pattern. This is done using 1 tile, and it is a pattern. The problem is just that it's really ugly. Ideally, we want to visually get rid of repetition, and we often want to highlight the edges of our platform. We want our tiles to look something like this, or perhaps like this. And how I've done this in the past is by drawing 47 tiles. Why 47? Well, as Jess Codes mentioned in her excellent video, in order to exhaust all possible configurations for neighbors, you technically need to draw 256 tiles. But in practice, you can get away with 47, which is what most people do. Now with normal tiling methods, if you want to use fewer than 47 tiles, this is possible, but it comes with drawbacks. You either get visual issues or issues with your visuals not matching your colliders. So many people make the annoying choice of drawing those 47 tiles, like I've done here. Now even 47 tiles can still come with compromises. A tile set like this is 47 tiles and looks quite nice. But we can see here that the visuals on the tile is completely square. And if you want to have slightly rounded corners like this and have some grass protrude from the collider, then this is also possible with 47 tiles. It's just that now your colliders have to be smaller than each tile, which we can see here. Which means that even if your tile itself is 128 by 128, your collider, it won't be 128 by 128. It's technically something that is workable, just potentially more cumbersome to deal with. So Jess Codes described this problem with handling neighbors and collider issues and proposed a solution. Use 2 grids, one for colliders and a separate grid for your visuals. So in the normal way we do auto tiling, the single grid system, if you wanted to place a tile, your engine would check if there are any neighbor tiles, and if there weren't, it would select the tile you have drawn for no neighbors. And this tile would have its own collider attached to it, and this collider would match the grid. Now if you wanted to place a neighbor tile, you would check if there were any neighbors, and instead of using this tile, you would pick this one that has a neighbor to the left, and this one that has a neighbor to the right. And now if you placed it in the scene, we will get this type of combination. And obviously you don't want to be the one manually doing this, so you set up your engine to do this, using something like auto tiling, so that you can just paint and have it ending up looking nicely. But in a dual grid system, it doesn't work like this. Instead, we ourselves make a tile like this ugly gray box, and to start with, we attach a collider to this ugly gray box. We start out with the normal tile map layer, and now we can place a tile. So seemingly, this is just like the single grid system. But now, on top of the world layer, on top of our first tile map, we now add another tile map. And I've called this layer here our visual layer. It's our visual tile map, where we add our visuals. So we have our ugly gray tile here, and then we have a secondary grid for making stuff look good. So unlike our single grid system, where our colliders and our visuals are both on the same tile map, in our dual grid system, we have one tile map for colliders and a separate one for visuals. So in order to get our colliders and visuals to kind of overlap, we have our visual tile map offset by half a tile. If this orange grid here is our world layer, when we select our visual layer, we can see that this orange grid is now offset half a tile from where the gray box is. Now this might seem kind of weird, but bear with me. Instead of drawing a normal tile for a block like this, we just start by drawing a corner. Now we look back at our scene, and we look at this box, and then we look at our visuals. We don't have a box tile, we only have a corner tile. But now, since our grid is offset by half a tile, this isn't a problem. The gray box beneath it only covers the corner of the tile. So we add a corner and now this tile is covered. And for the other edge of the box, this side, we need another corner. Well, no worries. We can just flip this tile that we drew in our engine, like this, and then add it. Then we flip it again, and we can add a third corner. And same for our fourth corner, and now we have a box. So for this one underlying gray collider, we have to match it with 4 visual tiles, 4 corners. And now if we were to go back to our world layer here, and we add another neighbor, now we have to change these 2 corner tiles to match. So the question is, what kind of tiles do we need? Well, it looks like we need a tile like this, and a tile like this. Same type of tile, but flipped. So we draw tiles like that, and we place one, and then another, and now we need to match these corners again. So we take our corner tiles, and now we have a visual layer that perfectly matches our underlying world. So this might seem a bit weird and cumbersome when I show it to you manually like this. But first and foremost, we can see that the visuals match the underlying gray box. Our visuals match our colliders. And more importantly, even if it looks like we have to draw more tiles, 4 to cover a box like this one instead of 1, that's actually not really the case. You have to remember that this gray box is a 128 by 128 tile, and these are 4 corners of a 128 by 128 tile. Add all of these corners together, it's 128 by 128. So it's more tiles, but we aren't actually drawing more tiles. In fact, this offset that we're doing is precisely the reason we get to draw fewer tiles. Because if we look back to our 47 tile system, there are a lot of tiles here with corners. This tile has a corner, this tile has a corner, this tile has 2 corners. Now for all of these type of corner cases, instead of drawing those corners would just be replaced by our corner tile. So now we don't have to draw lots of corners, we just have a corner tile to cover all those cases. And this tiling system I've shown here is not something we do manually anyway. We still let our engine handle the tiling. Now in Jess Code's situation, she made 15 tiles for her dirt grass transition. It looks great and has all these benefits that you get with the offset grid. But she referenced 2 other videos, one by Thin Matrix, as well as a talk by Oskar Stålberg. And in that specific talk by Oskar Stålberg, he basically showcased this principle that Jess Codes talked about, but using only 6 tiles. 1 tile for water, 1 for land, an edge corner, a straight tile, a nook, and a double nook. The reason Jess Codes got 15 instead of 6 is, as far as I can see, just that she drew the rotations. But as you saw in our case, you don't have to draw the rotations. You can just rotate the tile in your engine, which is what I did here. I drew 1 corner and then rotated it. So now if you follow this principle that Oskar Stålberg talked about, now we can get away with 6 tiles. Or if you're doing a platformer, like we are, we can get away with 5. Because you don't have to draw the empty tile. So does all of this work? Well, I think so. Here's my grass example, and as you can see, regardless of how I draw it, it looks fairly decent. And how does my texture look? It only has those tile types that Oskar Stålberg mentioned. A corner, a straight tile, a nook, and a double nook. And then a fill tile for our grass. And then in Godot, I've set up rotations as alternative tiles. Okay, but what if you want to make a nice brick style pattern? Well, let's try it. So if we draw a simple brick pattern like this, and then we place it in game. Initially it seems like it looks good, but if we place a couple of tiles, and then look at it, we can see that some of this brick pattern doesn't line up. It looks kind of horrible and bad. Because we rotate each and every tile, we can't make our brick pattern match seamlessly. Similarly, we might create a brick pattern like this, slightly different, but some cobblestone type of thing, and have it look good here, but then we place it in our scene and it just doesn't quite work. It doesn't line up well. So we have this brick pattern look good here, but then we place it in our scene and it just doesn't work as well. This isn't impossible to fix. One thing we can do to handle our orientation problem is to fade the interiors to black. And now we can see that it visually lines up quite well. Even though the asset on the edges looks identical to before, now that we don't see the interior, we don't really have to care about what would happen there because it's faded to black. But what if we really want this type of brick pattern? The one we saw in our 47 tile version. This obviously didn't work. Well, if we instead of filling our entire tiles, we only fill in the corners like this, and the rest of it here we keep transparent. And then instead of placing this ugly gray block below, we place a seamless rock pattern like this. Now if we combine the two, we get this seamless interior, while at the same time we get these nice edges. And we're still technically only drawing 5 tiles. 4 tiles for the edges, and the 5th interior is just on another tile map. Now I will say that this is just one way to do it. Jess Coates made a follow-up video where she discussed how you could make this interior seamless by using shaders, which also seems like a workable solution. All of this to say that when it comes to tiling your game, the dual grid system offers quite a bit of benefits. And basically from a visual standpoint, you can achieve the same or better results using fewer tiles. And all of this means that you free up time to draw more intricate assets, like this fairly intricate tiling that took me 40 minutes to make. As a base comparison, this is my implementation using 5 tiles, and this is one using a similar texture as Jess Codes with 15 tiles. These two are functionally equivalent, and we can compare these two with my 47 grass tile texture, where there is a difference. But I would argue that the fact that this grass texture is significantly smaller than each tile is actually a downside. So I prefer this result that we get with the 5 tile texture. And obviously, my implementation here is kind of squarish, whereas Jess Codes tiles are more rounded. This is just a matter of taste, and how you do it will be up to you. So the question you might be asking at this point is why this approach isn't used more often. And well, I don't really know. I suspect many people just haven't heard of it. On top of people not having heard of it, I don't think any game engine natively supports this solution. So you're stuck implementing your own solution, which might scare some people away. But if you're making a game with a lot of tiles, and you feel somewhat comfortable programming, I want to just take you through my code to show you the basics of how you can implement it. This will relate more to those that use GDScript and Godot, but a lot of it should be transferable to Unity or gamemaker, or basically any engine. You can obviously check Jess Code's video as well, it's good. So bear in mind that everything I show from now on is made by someone who doesn't have an excuse to write bad code, but I still quite often write bad code. So first thing I want to point out is that all of this tiling has been done in-game and not in the editor. So I can walk around here and then I can place tiles. And that's because all of this tiling is done using a script, same way as Jess Codes. That's also why you can see a save button up here in the corner, something I use to save any changes I've made to the tile map. So sometimes I save it and sometimes I don't. So the main principle this works by is that you want to associate this visual grid to this world grid. We wanted to have this type of overlap. And I want us to first start by looking at one of the simplest methods of implementing this, where we only have one tile texture. So something like this, our grass tile texture, and we only have 2 tile map layers. Now if we add one of these gray blocks to our collider grid, our world grid, and then we select our visual grid. Now if you imagine that we're this visual tile, the gray block beneath only occupies this quarter of the tile. Now if we add another gray block to our collider grid, like this, and then we go back to our visual layer, now the overlap for our 2 tile grids is for this quarter and this quarter. And if we were to have a gray block here, then the overlap would be for this quarter and this quarter. What this means is that if we want our visual tile to be able to overlap our collider tile for every single circumstance, we need to imagine our visual tile as consisting of 4 quarters. Each quarter can be viewed as a 1 if it has a collider tile below it, or 0 if it doesn't have a collider tile below it. And so our job is to exhaust all possible combinations of our visual tile having a tile below it or not. And if we go through every single combination, we end up with 16 possible combinations. So we need to exhaust all combinations of our visual tile having a tile below it or not below it. Now we can write down all of these combinations as an array, where from the perspective of our visual tile, the first element in our array would correspond to the first quarter in our visual tile. The second element would correspond to the second quarter, the third element in our array would correspond to the third quarter, and the fourth. It would correspond to this line in the script, 0, 0, 0, 1. Now all we have to do is to map these arrays to the atlas coordinates in my visual tile. So for our 0, 0, 0, 1, we need to map it to our atlas tile with this coordinate, which in this case is 0, 0. Which we can see, the atlas coordinates 0, 0. Now if we do this mapping with a dictionary, now we can easily translate every single tile combination to a specific tile in our atlas. As for how I place my tiles, I've just set up some input events, and then I check for the mouse positions and then what that mouse position would correspond to in my tile map, and then I place my world tile on that position. Is it that simple? Well, no. All this does is that it places our ugly gray tile. Now we still need to place our visual tile. And as you recall, when we place one gray tile, we're actually affecting 4 visual tiles. This tile, this tile, this tile, and this tile. So now we kind of have to do the same. So I did this using a nested for loop. So I first placed this tile, then this tile, then this, and then this. There are probably prettier solutions, but I actually prefer to write it poorly and readably, and then I optimize it if I need to. Not saying it's a good approach, but I prefer getting a workable solution as quick as possible, not the ideal solution slowly. So this for loop places each of these tiles. But before we place any tiles, we also need to check what each visual tile has as a neighbor on the collider grid. What does our visual grid has as a gray box beneath it? So for each loop, we have to go into a separate function, a neighbor checking function. And in this function, I write out an array, like we can see in our dictionary, and then once again a nested for loop. And now we can just go through each neighbor coordinate from 0, 0 to 0, 1 to 1, 0 to 1, 1. And if I get back that there's a tile there on the world layer, then I update my array on that position with a 1. Now this line might seem spooky, but it basically just checks if there's a tile on the collider layer. The chord here is the visual coordinate for the tile we're on. The negative 1, 1 vector here is just to handle that our visual tile grid is offset by half a tile. And then the plus xy is just so that we can loop through each of our 4 neighbors. It looks scary, but it isn't really scary. So when we run this function for our scenario here, the first neighbor will get back a 0, the second would get back a 0, the third a 0, but the fourth a 1. And then we would return the array. So once we get back all of this, we would know to place this tile. The problem now is that you can only place tiles, but you can't delete them. So this is easy, right? We just go erase our world tile at our mouse position, and then go through each visual tile and erase those. Right? Well, not quite. If we call a separate function to delete the visual tile, and now we look at that function, the problem is that once you erase a gray block like this, you don't necessarily end up with an empty visual tile. Suppose we have a situation like this. We have 2 gray blocks on each corner. For this visual tile, we have 1, 0, 0, 1. And so now the visual tile we have to place to match this situation is this one. But what happens to this visual tile if we now remove this gray block? Well, we can't just delete this visual tile because it's not completely empty. It's not 0, 0, 0, 0. It's 1, 0, 0, 0. So when we delete this tile, we also need to replace it with a visual tile that matches this corner. And the easy way to solve this is once again a for loop, and then we erase every cell, and then we just use our previous function to place a new tile. And now we can both add and delete tiles and have them line up nicely. And as it stands, if you only want a single tile texture like this is basically the only code you need. It's fairly simple, not the most cleanest code, but you can place tiles and delete tiles however you want. And then if you just add a resource saver, you can save this tile map, and now in the future, you just load this tile map from disk and it gets updated. The code is only important for placing tiles, but when they're placed and saved, the tile map will be updated in the editor and look nice and tidy here. As it stands now, the fact that this code runs in game does mean that you can't really place tiles in the editor. So if we place tiles here, we don't get that clean, nice grass look. If you want to be able to do this though, you can fix it. So we can write a recalculate map function where we clear the entire visual layer, and then for every gray block we just place a new tile. And if we run this code, we can see we have a lot of gray tiles here. We can see that it updates immediately. So now you can place gray blocks in your editor and have them update in game if you want to, and then save it. And as we can see, this both looks fairly nice and decent, and more importantly, it's done using just 5 tiles. The problem comes when we want more textures and more complex stuff. You see, suppose I add a lot of tile textures to my tile map, and then I add some functionality so that I can iterate and change between them. So that now in game I can cycle through different tile textures. And now I place these tiles. This should work, right? And kind of. You can see I can place grass, I can place sand, I can place rocks. So seemingly, we can cycle through different tile textures. Well, kind of, but not really. You see, if I place my tiles randomly like this, then it kind of looks okay. But suppose I have my grass texture like this, and I want to place an adjacent rock tile. Well, now we can see that it kind of starts destroying itself. We don't have a nice rock-grass mix tile, So they will overwrite each other and look kind of weird. We get this kind of weird mix. Every tile just destroys itself. So if you just place one tile, then it works. So in order to properly solve this problem, we have to change something. And one option is to make the grass-dirt mix textures that we talked about. So that whenever you use a grass-dirt mix, we would map it to such a tile. This might make sense if you only use 2 tile textures, and perhaps even if you do top-down. But if you want to have a crazy intermix of tiles, such as this, making all of these transition tiles would be quite cumbersome. So are there any other options? Well, I think so. I do want to note though that this next implementation might be bad for performance if you scale it up. I just want to show you that it's possible to extend. So how I've implemented this here is to make a separate tilemap layer for every texture that you would use. And the code doesn't become significantly more complex. Instead of placing on just your visual layer, I store each tilemap layer in a list, and then I map each tile texture to a specific value. So since my rock layer is the second layer, I just map rock to 1. And since my grass layer is the 5th layer, I map grass to 4. Other than that, there isn't much to it. You just have to make sure to map the correct texture to the correct tile map. As I said, I don't know entirely how this implementation would scale in Godot 4.4. But some of you don't need to worry about performance, and you can at least see that this weird intermix of tiles would look nice even though it's only 20 different tiles. So this is just the basics of the code. But you can obviously extend this further and further. You can add a randomize function so that you can rotate between equivalent tiles. You can even add an extra value in your dictionary so that you can sometimes have it so that the top of your tiles look different from the bottom of your tiles, and other times not. Whatever you add isn't that difficult to add, and a lot of your code will depend on what you want to do with it. I set up my texture to be a column like this in order to have an easier time handling tile variation, but I did it only for convenience sake, and there are problems with it. So I'm not saying copy how I do it, but I'm just saying that it's possible to do and you can fix and make it nice. You can see that my really simple and kind of naive solution that I implemented for this video specifically kind of works. I only have 5 tiles and it looks good. And to add to that, I don't think it matters too much if this code is poorly written. You see, as long as this code runs, I just use it to place tiles and update the tile map. Once you like your tile map, you just press the save button in the corner. It doesn't matter how inefficiently the tiles were constructed. It only matters that the tile map works like it should. How this is written at the moment is not how I'm going to use it either. I'm personally probably only going to use 2 tile map layers, the world layer and the visual layer. I only made this type of crazy intermix to show you that it's possible to extend it if you would want to. I don't personally want 5 tilemap layers. So are there any downsides? Well, I think your immediate thought might be that 5 tilemap layers are bad for performance. Or perhaps even that part of my tiles are transparent will result in a lot of overdraw, which will also be bad for performance. But I personally don't think it's the end of the world, and it kind of depends what game you're doing. This is some speculation on my part though. I really hate this aspect of making videos like this. I do think the dual grid system is cool, but I can't vouch for it being the best thing since sliced bread in all regards. I also have just personally started using it, so I don't know exactly whether there will be performance issues or where they will come from, or how to best solve them. But while I have this implementation, I thought we could do a simple quick comparison with a single grid version for a big tile map plopped just straight into an empty scene. We can kind of see my FPS, my total objects drawn, and my draw calls. And if we compare this big tile map to the big intermix with lots of tile map layers, we can see that we get a hit in FPS. Obviously, if we just check the draw calls, this looks really good. But just checking draw calls in this situation would be really misleading. There is obviously more overhead to the tile map layer that might cause performance issues. Stuff that we don't see here. But you can see, at least in my situation, when my really terrible computer has a big single tile map running and does 900 FPS, then for that same tile map, using my implementation of like 7 tile map layers, I end up with a comparative 700 FPS, which is perhaps not ideal, but I don't know for sure. In my opinion, this performance stuff for tile maps can be tricky to test. As I said, you can't just necessarily assume low draw calls equals good. Here's an implementation I did without using any tile map layers for the visuals, and we can see it's only 1 draw call, but it's still awful performance. Now in this situation, the issue is probably the primitives used. My point is just that you can't necessarily simplify it to just draw calls. Similarly, you can't just assume that 1 tilemap layer equals good. If you were to do this weird thing I did earlier with several textures on 1 tilemap, you can see that it's quite bad for performance. Low FPS, lots of draw calls, which kind of seems reasonable if you think about it. Changing textures on a tilemap layer ought to break batching. And it seems that we are breaking batching here. I can't find any documentation on it, but it looks like it. But as I said earlier, I don't think any of what I've just mentioned means that the dual grid system is necessarily bad for performance. I truly do believe that there isn't any reason why the dual grid system wouldn't be able to run just as efficiently as the normal single grid system. If it's implemented optimally, that is. I'm just not going to be the person to implement it optimally. So should you do it? Well, I think it looks fairly good from the few tiles I drew to test it. And having to draw only 5 tiles means that you can make those 5 tiles look good. The only thing that's annoying, I guess, is fixing the code. But I think this solution from a game art standpoint scales better. You simply have to draw less, which is awesome, even if you love to draw. All of this to say, unless I missed something, I think it's kind of cool and nice, and I personally plan on using it for my game when I eventually start adding game art. Feel free to comment if I did or said something stupid. Oh, and I'll probably upload the world layer script and these textures for free on my Patreon if you want to take a closer look. I'll also upload a talk where I discussed how I drew these tiles on there. I won't upload the entire project files for the code though. If you want a plug and play solution, you shouldn't use mine. You don't want to adopt my bad coding practices. I talk about game art for a reason. Thanks for watching. Bye.